Welcome to topic 1 in our unit on fluids, which covers a bunch of physics topics. So we're going to deal with the particle theory and what a fluid really is. Let's look at this quick YouTube clip and then we'll talk about what's going on here. Whoops. So that's pretty amazing. Here's another one. And so how is that even possible? Well, let's talk about it. What they're really running on is kind of a special fluid. What they've done is they've created a huge pool and they've added some cornstarch to make the water a cross between a liquid and a solid. So sometimes it behaves like a liquid, sometimes it behaves like a solid. So let's get into how this is possible and what fluids really are. We need to know the particle theory to understand how fluids behave. And so let's talk about the 5 important parts to the particle theory. All matter is made of tiny particles which are invisible to our naked eye. Particles of one substance look differently and have a different shape and size than particles of another substance and behave differently. They have different physical and chemical properties. For example, a water particle has one oxygen and 2 hydrogen bonded kind of in a V shape, and it has a different size and behavior than if we looked at, say, a particle of oxygen or whatever. There are attractive forces among particles, and some substances have stronger attractive forces than others. We'll learn about the concept of density. The closer the particles are packed together, the stronger the force of attraction, which is why solids are harder to break apart than liquids, and liquids are harder to break apart than gases. Here's a tank trying to show you maybe what gas particles might look like, and one thing you should notice is if we could see the invisible gas particles, we'd see that there's huge spaces between them. They have low density. And particles are always moving. The more energy they have, in other words, how hot they are, the faster they're moving. And of course there are spaces among particles which help determine things like attractive forces. Here's the particle theory again. Here's how cold particles might look compared to warm particles in water. And the biggest difference that you should notice about the two different pictures or animations is how much faster these hot water particles are moving. So speed of the particles. Liquids are considered fluids because we can pour them. In other words, they flow. And gases are fluids because we can also pour them and they move and they flow. And what does that say then about the attractive forces and the spaces between the particles? Well, liquids and gases have weaker attractive forces, and therefore that allows us to pour them. We should remind ourselves about the 3 states of matter: solid, liquid, and gas, and the fact that it's very difficult to squash a solid and the solid can't be poured. It's not as difficult as a solid, but a little more difficult to squash a liquid, and they can be poured, and it's easy to squash a gas and they can be poured. A better term than squash we use in physics is the term, and chemistry is the term compress. So gases can be compressed, and that's due to the large spaces between the particles. Liquids are virtually incompressible, and solids are definitely not compressible. And that's due to the spaces. Very little space, a little more space, even more space. Particle theory explains how this happens. So in a solid, the particles are fixed or vibrate. Sorry, they vibrate. So the word vibrate would go there. Around in a fixed position. There is a force of attraction between each particle, and they're very close together. Let's look at liquids. Liquids, the particles are close together still, but can move in any direction, which makes them a fluid. They won't keep a shape, so if they won't keep a fixed shape like solids do. In a gas, the particles are very far apart and move quickly in all directions. They often collide with each other, and they can be easily because they are far apart and can be easily separated. We should know how to go from solid to liquid to gas and what these terms are. So solid to liquid particles, what are we doing here? We're melting. Liquid to gas, we're evaporating. So evaporate. And we can also go from a gas down to a solid, and that's sublimation. And we can go this way too, sublimation up. So when we travel in this direction, we're applying heat energy. If we travel from here to here, what do we call that? That's condensation. From here to here, what do we call that? That's called freezing. Sublimation up would be like dry ice, carbon dioxide frozen, being released into the room to create fog. Sublimation down might be something like frost showing up on your windshield in the morning. What are these processes called? Is this freezing, evaporating, condensing? So this would be condensing right there. And this, of course, would be freezing. So we know that solids can't be considered fluids. Only liquids and gases are fluids. And that has to do with the particle theory and how fixed the particles are in a solid, which means they can't move past each other, whereas liquids and gases can flow. Well, there are two types of flow I want to present to you. One is when a liquid or gas goes around an object, the flow could be very smooth looking, and we call that laminar flow. However, if the flow around an object, like a golf ball, chops up and kind of spins backwards, we call that turbulent flow. So laminar flow might be the water coming down straight from a tap. Turbulent flow might be the water when it hits the sink and starts to kind of spin around. And we use aerodynamic shapes through fluids to help create more laminar flow. So nice streamlined shapes like the airfoil on a wing of an airplane help create better laminar flow than turbulent flow. And so one of the things they realized with the dimples on a golf ball was there was less turbulent flow here when dimples were put on a golf ball. So when air goes around the golf ball, there's less opportunity for turbulent flow, thus making the golf ball travel farther. Let's look at this clip on solids, liquids, and gases before we end this session.
Solid, liquid, and gas are the three states of matter. Each state has different properties. These different properties are due to the way in which the particles are arranged in them. In a solid, the particles are packed tightly together with strong forces holding them together. The particles cannot move, but they can vibrate. In a liquid, the particles are in contact with each other, but there are only weak forces between them. They can move and slide past each other. In a gas, the particles are further apart. There are very few, if any, forces between the particles, and they can move freely.
And that concludes our first section on particle theory, as well as why something like a gas here is a fluid and of course a liquid. Bye for now.